All right, for number 7, the domain is all real numbers. All right, what am I looking for? Derivatives now. So as I write this down, be careful about it. Write the function down. I'm going to write it as a product, by the way. I'm going to say the first function is minus 3x, and the second function is e to the minus 7x. And let's go to town on it. First derivative. And I'm going to say the first function, minus 3x, times the derivative of the second function, which is e to the minus 7x, times minus 7. I'm doing the product wrong. And it's going to be plus the derivative of the first function, which is minus 3, times the derivative of the second function, which is e to the minus 7x. And I think it's in my interest to just simplify that a little tiny bit. So what do you get there? And I'm kind of looking at it. I'm going to say, looks like you get 21x e to the minus 7x minus 3 e to the minus 7x. I'm going to factor out a 3, and I'm going to factor out an e to the minus 7x. What do you get there? 7x minus 1. All right? Now, if someone says, looking at the key and the answer has got to be wrong because it's not the same answer. It's the same answer. The only difference is I factored out a minus 3 in this one. This one I just factored out a 3. It's the same result. All right? Okay, I want to go to the second derivative now. All right, put that down. By the way, if the first derivative is wrong, second derivative is going to be wrong. I'm still doing the product rule on it. All right, so I'm going to say the first function, 3e to the minus 7x, times the derivative of the second function, which is 7, plus, the derivative of the first function, which is minus 21, e to the minus 7x, times the second function, which is 7x minus 1. And again, it's in your interest to simplify that. And the way I'm going to do that, looking at it, I'm going to factor it. And the way I'm going to factor it, I'm going to say, let's take a look at that. I'm going to say 21 is common to both of those terms. I'm going to say e to the minus 7x is common to both of those terms. Let me see if I did okay on that. Let's see, 21. I want to check my work too. And let's see. F prime. Let's see, I'm checking this over here. And I'm checking my derivative now. First function, derivative second. And then you got the minus 21 e to minus 7x. Yeah, I think I did okay. Let me keep going. And what do you get over here? Well, let's see. You get 1. That's going to give you 20. Yeah, that's pretty good. And then you get minus over here. I factored out the 21 e to the minus 7x. So it's minus 1 times 7x minus 1. All right, let me take a look at that now. And it's a little complicated, isn't it? 21 e to the minus 7x. And let's look at the inside over here. What do you get? 1 plus 1, which is 2, minus 7x. All right? So it's tough, and I realize that. We're looking at the second derivative. And you should always wonder, do I get these things right? Let's look at it. Look at this over here. Yeah, we got it okay. We're doing all right. What am I going to do now? I'm going to answer the question about the point of inflection. And looking at it, although it looks like it's tough, it's not, because, when does this thing take on a 0? That's pretty simple. It takes on a 0 at 2/7, and that's the only place it takes on a 0. And everywhere else it's defined. So at 2/7, that takes on a 0. The next question is, what's the sign of it if you go to the right and left of it? And I'm going to say a good test point over here would be 0. And if you plug it in here, that's where we're plugging it in, what would you get? 21 times 1, and then you get, it's all positive. I'll put concave up. If you go past 2/7, and to play it safe, I'd say 100. What do you get? Well, the first factor is always positive. And if you do this factor over here, it's going to be negative, so it's concave down. So what do I know about this over here? I got a point of inflection, POI. And that POI is going to occur at 2/7. The concavity changes over there. And f of 2/7. No, I'm not going to compute that. Right? So let's just talk about the intervals where it's concave up, concave down. But before I do that, they clearly do say that the point of inflection is at 2/7. Where's the concave up? Well, concave up over here, which is minus infinity up to 2 7s. Where's the concave down from 2 7s off to infinity? Thank you.